Hello and welcome to Synerise Smart Sessions. My name is Jacek Dabrowski, Chief AI Officer at Synerise. I'm leading the AI team at Synerise. So basically the team building machine learning solutions and our AI suite. And then today I'll tell you a little bit more about what Synerise AI is, how we do it, and why we do it. So let's get started. The agenda briefly is as follows. First, I'll tell you the definition of Synerise AI, how we see it, how we understand AI at Synerise. And then we'll go through how does Synerise AI work in practice. Then we'll cover how and why we win. So basically how we have created a leading AI solution on the market, not only leading in the business sector, but also leading in academia and leading in the whole deep learning world. And last but not least, thinking outside of the box. So how you can apply Synerise AI to unorthodox scenarios. Let's get started. So what is Synerise artificial intelligence and how is it different from other applications of AI that you may have heard about? For sure, you've all heard about AI being applied to image processing, identifying people in videos, maybe the YouTube feed, how it gets personalized, maybe some robots controlled by AI, maybe even AlphaGo, so the DeepMind version of artificial intelligence playing games. There are many different kinds of AI, but our focus at Synerise is on applied artificial intelligence. So we base our thinking about artificial intelligence on three pillars, three key requirements. The first and most ambitious requirement that we try to satisfy is to be able to ingest heterogeneous multimodal data. What does that mean exactly? Well, heterogeneous means that the data comes in very different forms. It's not of a static format. You may think about banking data to be fairly static. You may think about typical e-commerce data being fairly static in terms of the structure of the data. But at Synerise AI, we try to approach data in a very fluid fashion. So our algorithms tend to work with schemaless data and extremely rich data. For example, adding a new data source is very simple, just feeding in new data into Synerise. Customizing the features of the data is also possible. That's one of our primary goals, to be able to support very dynamic data environments where changes can happen daily, weekly, pretty much on the fly, instead of being frozen to some predefined set of fields that we want to consider, like in finance. Finance is pretty much ancient in terms of the data schema they're using. Now, what does multimodal mean? Multimodal data means data coming from different domains. So the typical domain that everybody is used to is tabular data. For example, you have a table with rows representing customers' transactions. This is a fairly common type of data, especially in business, but there are more. So there are types of data where the data does not fit into a table. For example, visual data, images, video, text data, short text, long text, any kind of data with natural language processing requirements. So we try to support all those different kinds of data in a fairly consistent way, so we can gather and collect all the types of events the customer may want to collect in their system they may want to consider and base reasoning upon that data. So we are not limited by any data modalities, and we can capture all of that information very nicely in one place. That's the first pillar, to be very flexible regarding the data. The second pillar of Synerise AI is a thing we call automatic behavioral modeling. What does that mean exactly? Well, in a typical data science scenario, you have people dedicated to creating so-called features. So for the people listening who don't know how data science works, basically, once you have some raw data, for example, in a tabular format, the data may represent, let's say, your banking transactions, your credit card payments. Now, a table containing your credit card payments is usually fairly useless for a machine learning model because it's raw, it's unprocessed, and it does not represent you as a person, but it represents the singular events that you have generated. So every row in that table is one financial transaction. And that's bad because a machine learning model, to tell us something about you personally, needs to have data in the form of a single row representing a single person. So how to take your bank statement containing multiple line items and convert that into a nice row or a vector representing the totality of your individual behavior over some time frame, let's say 1 month. That's what data scientists tend to work on. So they usually take raw data coming from whatever data source and spend months or at least weeks, dozens of weeks, on transforming that event level data, line item data, into aggregates, so that a single aggregate can represent a customer, or that aggregate can represent a product or any other entity. Well, at Synerise AI, we take a very different approach. We try to eliminate the boring work. And how we do things is we do automatic behavioral modeling. So whatever entity may interest you, whether it's a customer or a product or a device that has some events linked to it. For example, me as a customer of a grocery store, I have multiple events representing my transactions, my purchases. I have events representing my online activity, and I have events representing my mobile app activity. So Synerise takes away the necessity to create features manually for all those types of data. And instead, what you get after feeding in the raw events are so-called unified behavioral profiles. So underneath the Synerise engine, what happens is all those events are transformed automatically into very nice vectors representing the historic interactions of a given entity, so a customer, for example, or a product. And all those raw line item events get compressed into that neat representation. So that takes away a lot of boring work, and it works, as we have proven many times, much better than manual feature engineering. So that's an absolutely stunning effect that we've achieved here. And the third pillar, as important or as the other two, is real-time machine learning execution capabilities. So in most companies doing data science or machine learning, large organizations, how things work, when new data arrives and a new model is built, you don't get results in real time. The calculations tend to run in batches. So a batch may take, let's say, 48 hours to be calculated. And after those 48 hours, the results are available in the form of a report or a table or a CSV file. And then people take that output and do something with it. For example, they create a campaign acting on that machine learning output. We do things very, very differently at Synerise. So all of our models, literally all of them, are designed to always work in real time. So once something changes, for example, I, as a customer, go to an airport, withdraw money from an ATM, and then go to one of the stores at the airport and purchase something, and that information comes into Synerise, then immediately the unified behavioral profile representing my behavior gets updated, and all the models, all the predictive models for recommendations, for search, for personalization, for time optimization, for anything you can imagine, they already have that updated state. They don't need to wait 1 week until some batch is calculated. But they already have my latest behavioral information inside, ready for the fresh decision to be made. So those three pillars, I believe, make up a very interesting offering that's very hard to achieve for our competitors. To give you some examples of different input data that Synerise AI can consume, we'll go briefly through the business sectors. So one of the primary sectors we're working with is retail, online and offline. So the data we can consume are, for example, shopping carts, page views, online transactions, offline transactions, mobile app usage, and some more stuff as well. For banking, we can collect credit card payments, wire transfers, SEPA transfers, ATM withdrawals, online activity, mobile app usage. We can collect call center activity, for example. For the telco sector, we can collect phone call logs, SMS logs, internet usage data, and by internet usage, I mean which domains does the customer visit, which servers do they connect to, call center interactions, online web portal activity, mobile app usage, if the telco has a mobile app. But there are other industries as well, like travel. We can collect hotel reservations, airplane ticket orders, destination searches, and check-ins. Obviously, there are more possible applications. Pretty much anything you can imagine where there is a meaningful interaction between the customer or their device or some entity representing the customer and another entity, like a product or a URL or some physical good or an email address. All of those are valid interactions that we can collect and we can process automatically using Synerise AI. So what does AI give us, really? Well, AI obviously can play games, as you know, from AlphaGo and some other very nice showcases. But in terms of business results, Synerise AI can help us predict preferences, like, for example, which brand do I prefer, or which foods do I prefer. It can predict behaviors, like which product am I going to buy, or what price am I going to find attractive. It can predict propensities. So in terms of grocery, for example, what is my purchase propensity in the category of bottled water? It can predict the timing of behavior as well. So for example, if we have data about the customers using their mobile app, we can predict the next time they are likely to be using the mobile app as well. In terms of effects, AI can recommend, for example, it can recommend products, categories, attributes. It can recommend activity times. And from the business standpoint, it can optimize. So obviously with good personalization, with good execution, with real-time responses, we can optimize customer happiness because the customer gets relevant content and the targeting is precise, so we don't bore the customer with irrelevant offers. And we can optimize the timing of things, so we don't wake up the customer at an inconvenient time, or we don't spam them during work hours when they are busy. The bottom line is AI can allow us to replace manual rules and execution scenarios, which would normally be set by a large team of people thinking very strongly about how the customer may behave, what they may like, doing some manual segments, doing some market research. We can replace that or augment that with AI-based execution scenarios based on behavioral profiling. That helps to not only reduce the workload by a lot, but also it unlocks unprecedented accuracy. Why? It's quite easy to imagine why. Imagine that the bank employee looks at your bank statement in detail. They spend hours looking at your bank statement, so that once you step into that office branch of the bank, they can recommend the best products for you. They can do it at the right time. They can give you the right price, and everything can be tailored one-to-one, like in a private Swiss bank, just for you. That usually doesn't happen because nobody has time to go through your bank statements, to understand your behaviors, to understand why you are behaving as you are and what you may need. But AI has a lot of time and AI has a lot of processing power, so it can do that. And by doing that, you get a happy customer. So how does it work? Well, Synerise AI is not based on any open source or closed source AI products that you can buy. We develop everything in-house. All the algorithms are created by my team and myself. And it takes quite a bit of advanced mathematics to do that. But I'll give you a very brief overview. One of the products that we've open sourced is called Cleora. Cleora is a nice algorithm and software package that nowadays everyone can use because we made it open. It's just a fraction of our tech stack. But what it does is it converts huge graph data sets into very nice vectorized representations. So if you imagine that every customer is a little dot, and every product is a dot as well, then we can connect customers to the products they've bought. And this is how we get a graph, dots connected to some other dots. It's pretty meaningless without additional information for the human mind, but for AI, it's extremely meaningful. Because if you've bought a set of products, or if you have interacted with a set of specific people using your mobile phone, then AI knows quite a lot about you. For example, it can guess which people are similar to you based on your behavior. How does it do that? Well, it can take a look at which people made similar purchase decisions to you, or which people talk with the same people as you do. They're probably your friends or family. So Cleora is all about huge graph data. Huge graph data is very common in retail, in banking, in telco. What Cleora does is it takes a graph, represents entities as nodes in that graph, represents interactions as edges in that graph, and produces vectors for every node. So every customer gets a vector, every product gets a vector. And those vectors have very nice properties. For example, similar customers will get similar vectors, and similar products will get similar vectors as well. What can be done with that? Well, once we have those vectorized representations, we can ask questions. Questions like, should there be an edge between two given nodes? If one node is a product and the other node is a customer, then asking, should there be an edge, is asking, is that customer likely to buy this product? If we have two nodes and one is a product and the other is a product as well, well, then should there be an edge may mean, are these two products complementary products or substitute products? So for example, Coca-Cola and Pepsi, they will be very close in the vector space because Coca-Cola and Pepsi have very similar users. Now, the other type of a question we can ask is the node classification question. So once we know the vector of every node, we can ask additional questions about that node. So for example, we can infer demographic attributes from incomplete data based purely on the behavior of the customer. We can infer product metadata, like for example, what's the style of packaging? Is it nicely packed wine in a very old bottle, or is it some modern looking wine in a fancy futuristic bottle? All that information comes from the interactions. Why and how? Well, there are specific people who find the old, ancient-looking wine bottle attractive, and there are specific people who will find the modern-looking wine bottle more appealing. And based on the graph interactions, Cleora can infer quite a lot of information about products, about customers, about merchants, about phone numbers, about emails, and about everything that forms a graph. So just a few questions that Cleora is able to answer based on graph data. For example, what products may interest you? Where are you likely to spend money? Who are you going to call next? What's your social status? Who are your friends? Now, Cleora is just one part of our tech stack. There's a lot more behind the scenes, but one of the most important parts is called MD. So MD is short for Efficient Manifold Density Estimator. It's a mathematical model that we use for a very specific purpose. MD lets us create so-called behavioral profiles. So the unified behavioral profiles that I've mentioned a couple of slides before is created using MD. MD is a tool that's pretty unique because it allows us to aggregate multiple relation types and multiple data sources. So for example, in the real world, entities like people are described with multiple data sources, not only one. For example, for a person, you can ask the question, who does the user follow on Twitter? Which hashtags do they like the most? What do they buy in a grocery store? Where do they pay with a debit card? Additionally, products bought by the person or images liked on Instagram by the person are characterized with texts, images, and other metadata. Additionally, different interactions may have different strengths. So, for example, if I spend $100 on a product, it's a stronger interaction than if I spend just $1 on a product. Or if I engage on Twitter more with a given author, for example, if I like their posts 10 different times, that's a stronger interaction than if I did it just once. So MD is designed to capture all of this in a single unified format. How it works is it incorporates multiple data modalities using a nice technique that can be thought of as a very elaborate, highly advanced histogram. If you know what a histogram is, that's fine. Just imagine it happening in a multi-dimensional space with some curved geometry. If you don't know what a histogram is, you can imagine a map, like a geographical map, and you partition that map into regions using straight lines or some curved lines. Then you count how many times something happened in each region. And that's basically an analogy of a histogram. Except it happens with MD in any potentially kind of domain, like interaction vectors coming from Cleora, images encoded by a deep neural network, or text encoded by BERT or GPT-3 or any other language model. So just the important thing to remember is that MD can take multiple different data sources from multiple different modalities, for example, interactions, texts, images, and it forms, using all of that data, it forms a unified behavioral profile. So my behavioral profile would be everything I interacted with in the past. So every product I've bought, every person I've talked to, every image I liked, etc., etc. Every book I've read, for example, every tweet I interacted with. But the behavioral profiles are not limited to modeling people. They can model device IDs. For example, if we have an anonymous phone ID, mobile phone ID, if we have a phone number, if we have an email, if we have a product ID, a store ID, or an employee ID, the behavioral profiles can be attached to those as well. So just imagine that you have a product being sold at a store, and the product also has a behavioral profile that changes over time. So once a new customer buys that product, the behavioral profile of the product changes and evolves. You can also apply behavioral profiles to non-customer people, like, for example, call center employees or cashiers, and do modeling on them. The important thing about behavioral profiles is that they are maintained in real time. So immediately after something happens and the data comes into Synerise, the behavioral profiles are refreshed and they are enriched with that information. So they are always available for predictions with any kind of downstream model. So sorry about that slightly technical bit, but I believe it's good to know, at least on a superficial level, how it works. So let's get into how and why we win, because it might not be obvious that it's something really cool that we're doing here. So recently, we've won a number of really major international competitions. And by really major, I mean the top of the league, so the world class in machine learning and AI. One of those competitions was Seigyo Rakuten Data Challenge, co-organized by Rakuten, the Japanese retailer. And the challenge there was called cross-modal retrieval. Sounds mysterious, but the goal was basically to take a product feed containing products descriptions, their titles and long text descriptions, and images. The problem with the product feed was that the images were not linked to the products. So the task was for the AI to understand the titles of the products and their descriptions, often very long and in various languages, English, French, German, and match those descriptions to the photos. So that's called a cross-modal retrieval because we have text data modality and we have image data modality, two different modalities. The data set was pretty noisy, a lot of missing data, and pretty inconsistent in how the descriptions looked and how the photos were taken. We've applied MD, our unified behavioral profiling technique, treating both the images and the product descriptions as entities, and it worked. It worked the best on the market amongst industry and academia, and we won first place with pretty impressive results. Second recent challenge, very recent, was Booking.com data challenge. Booking.com, as you probably know, is in the travel business. So they do a lot of travel recommendation on their website, and the goal of the competition was aligned with their business. So the goal was to predict the final city of each trip of Booking.com customers. So we considered multi-hop trips with multiple cities in between, and our goal was to predict where will that trip end. And the dataset was huge, basically 1 million of real-world reservations. We had both hotel check-ins, reservations, and some other data in almost 40,000 unique cities in 195 countries around the world. We knew very little. So we knew the user ID, we knew the city ID, country ID, hotel ID, the class of the device, which didn't really matter, and the dates, check-in and check-out. Again, we applied MD. Doesn't sound like it might be a fit, but it's a great fit. Because what we did is we did behavioral profiling on the users interacting with hotels and with countries. So pretty much the same scenario as with product recommendations, where we track the purchases of the person. Here we tracked the interactions with the travel industry. Where did the customer check in, which country, which hotel? And we took the second place. NVIDIA has won, but NVIDIA's model was an ensemble of multiple different models, very costly, a lot of hardware, and quite slow to use. So we won the second place without pretty much any modifications to MD and to our default stack. The next competition we won very recently was KDD Cup Challenge in 2021. This is the World Cup in AI and in machine learning. So all the heavy hitters we have competed with Google DeepMind and Baidu Research. Google DeepMind, as some of you may know, is the team behind AlphaGo and all those shiny demos where AI is playing games. Probably the strongest team in the world. They are doing exclusively theoretic research with no applications. And Baidu research is like the analog of Google on the Eastern Hemisphere. The two strongest players in the world. We've taken the third place, and the competition was about classifying huge graphs of academic papers. So we had around 120 million of academic papers, scientific publications written in English. We had around the same amount of authors and 26,000 of academic institutions. The goal was to basically predict the primary subject area of a given scientific publication based on that graph exclusively. So this is a very, very different application, but the same framework. We've used MD, we've used Cleora without any strong modifications. We've taken the third place. Great success for the Synerise team. Our solution was the fastest and the cheapest to run, the only one not requiring very expensive specialized hardware. And the last competition we've won was the Twitter Rexis challenge. We've taken the second place after NVIDIA. The goal of Twitter Rexis challenge was to predict the engagement of users given a tweet. So the model has had access to the tweet metadata, the author, the text of the tweet, and some data about the user that's potentially interacting with that tweet. We had to predict whether the user will like, reply, retweet, or quote the tweet. And that data set also formed an enormous, huge graph of 1 billion data points from 28 consecutive days of Twitter data stream. Again, we've used Cleora and MD pretty much with no modifications. So what makes us different here? Because we've just went through 4 very different applications, 4 very different machine learning competitions, and pretty much none of our competitors have reused any model. All the models across those 4 different competitions were very different. They were handcrafted to match the given competition, while we have used the same approach to win 4 vastly different competitions. We've utilized a fraction of resources used by the competitors, and the beautiful thing is that the same technology underlies our products. So you can use the very same technology of AI behavioral modeling with our recommendations, search, time optimization, scoring, and our products soon to come. Last part, I'd like to inspire you to think outside the box. Because if you take a look at those 4 different competitions, probably not many people would approach all those 4 contests with the same model, with the same approach. We did that because we value thinking outside of the box. So if you take a look at product recommendations in Synerise, what about recommending movies, recommending hotels and travel destinations, recommending cultural events? Do you think that their recommendations are product-only recommendations? No. The recommendations can recommend pretty much any entity you would like them to. And they don't have to be products. They can be songs, cities, movies, or some type of concerts even. So just add a data catalog containing travel destinations, hotels, scientific publications, cultural events, a movie, or many other things you may imagine. There's nothing inherently blocking you from utilizing recommendations on things other than products. Then you just adjust the recommendation settings, set some additional parameters, apply some recommendation filters, and there you go. What about search? AI search in Synerise? Well, similarly, there is literally nothing stopping you from creating a search index on items representing any other objects than items, such as travel destinations, hotels, scientific publications, cultural events, movies, and many, many others. Then you can just set the searchable attributes, their importance, and some additional settings. And you can adjust the filters, facets, and there you go. You have a working search on a non-product entity in Synerise. So just a reminder, how can AI search be helpful? Well, first of all, it's blazing fast. It can show relevant items with photos and descriptions. Again, it can be hotels, it can be capital cities, it can be movie posters, whatever. It can use synonyms, correct common spelling mistakes. It works in several languages at the same time and can help you monetize product boosting. So the benefits of personalization are pretty obvious. Better customer engagement, better conversion and upsell, building loyalty and preventing churn, and increasing the chance for repeat purchases and replenishment. And that applies to any market, to any sector you can imagine. So be creative and stay tuned for more great products from Synerise AI. Thank you so much. That's all from me.